So it's not worth a whole lot, but I think it is due. So it's right here. Yeah, that's starting chapter 2. And I won't do Learn Smarts anymore after this one. This was mostly just get you guys into how Learn Smart worked. You are welcome to do them. You're welcome to work through them and read through the chapters and use it as a resource, but I'm not going to assign them anymore.
So no grade then?
Yeah, I'm not going to assign them anymore. I'm only doing this to get familiar with this system, that kind of stuff. The book's on you at this point, okay? I'm not gonna do the each individual, because it asks for reflective questions. So some concepts you guys know, and it's like, the reflective question is just poke me in the eye with a needle, For some of you, it's great, that's wonderful. But for some of you, poke me in the eye with a needle. And so I'm not gonna force you guys to do that. But I wanted you to see what was available, which is why I assigned them the first couple. All right, I also do the raw video, and I will warn you, I had trouble over in Enid on Wednesday recording. I don't know if it was me. I don't know if it was how we were connected and set up. I will figure that out, and so I will tell you, it doesn't have any of the .cam video on it. Just for grins and giggles, it has no .cam video on it. But you do hear the voiceover, so that may help or not help, I don't know. But we'll find out. We'll find out, and we'll play with it, and I'll find out later today whether or not I got it fixed by my other class, which I had over in the same room, whether it was me or when we were connected. But I know we're okay over here, so that part I do know. Now, let me find out. I'm telling you all of this, and I'm showing you all of this, and you guys have to tell me that you're not seeing the computer, because otherwise it will be fun. So there's the computer. So you've got the getting started in week 1, the raw videos down there. Your static photos, they're due by Wednesday. Okay, you can upload them either there as a part of the assignment or email me. And I've already seen a couple, so.
Do you mind?
I think I've got yours. I haven't opened them yet, but I think I've got yours. So I will be looking at that between the things that were going on last week and this week. I'm hoping I can catch up. And the fact that I haven't had 2 weekends in a row is made it a little more challenging. So that's where we are. And I will post this afternoon who's got what assignments. So just so that you guys have a reminder of who's got which problem. Okay? All right, homework. So if I look at the course material for week 2, it's right there. And that's your alarm for something.
I don't know. My bad.
Is that your computer?
Yeah,
It almost sounds like it's over that.
There, he got it.
Thing decides to go off whenever it wants to. I'm sorry.
That's not a problem. We're having fun. We're having fun. So, results and forces, it's right there. All right, so, and there will likely be a quiz in the near future. So just be aware, there will likely be a quiz in the near future. So for Militia 6.4.4, I'll see several of you bright and early Wednesday morning. Some of you I'll see Wednesday afternoon, and we've got it going. And you guys' report is due on Friday. You guys' report will be due a week from Wednesday.
Sounds good.
What?
Sounds good.
On the lab. Okay. All right, so now let's go to the .cam. Okay, so where we were on Friday, if we could sort of remember where we were on Friday. Hopefully things are working. We talked about the 2 conditions in equilibrium. We have the sum of the forces, and we have the sum of the torques. Those are going to equal 0. Those are going to equal 0. We reminded ourselves about action, reaction. So if I had the force due to gravity, I have a normal force going up. One of the things that we're going to talk about here is we refer to, at least in statics, when we're switching from that traditional engineering point of view, we're going to use a little bit of different terminology. So the fact that forces occur in pairs we actually start calling these things couples. Because for every force that we have in one direction, we know we've got a force out in another direction, and we call that a couple. So we will be dealing with couples as we move forward. Remember, we also dealt with things that we talked about, this being that we've talked about the fact that in physics, this is a torque, right? But in engineering, we're going to use a term called M, and we're going to call it a moment. Except we're going to use moments like couples, right? Remember, I talked about way back when, we talked a little bit about the difference between the two tire irons. That we had a tire iron that looked like this, and we have a tire iron that looked like that. Okay? And in the tire iron that looked like this, when we were trying to get something to move, we applied the forces that way versus the force like that in order to get our tire iron to move. One, I applied the forces in a couple. I applied two forces in opposite directions. And in one, I apply the force in a downward direction. So when we start getting to torques, we're going to actually do it as moments, and we're going to call them moments, and we're going to be dealing with them in terms of couples. So we're actually going to start looking at those pieces. So in statics, instead of the sum of the forces is equal to 0, and the sum of the forces, or sum of the torques is equal to 0, we actually end up doing the sum of the forces equals 0, and the sum of the moments equals 0. Okay? And it's just a different way of looking at a few things, of how we handle a few things. So some kind of reminders. And that's kind of what we're going to do today, is a little bit of reminders and then show you a shortcut. You know, so we can do a little bit of a reminder and show you a shortcut. So we did a problem, and we've seen this problem before. I've got a block sliding down an inclined plane. That's the angle. We're going to call this 30, and this is a 40. And we've got the mass of the block. So if I draw my triangle, again, there's this. This angle is the same angle that I have for my triangle. This is the force due to gravity, mg. This is mg sine theta. And we've dealt with these before. And if this block is in static equilibrium, and it's not sliding down the ramp, it's actually staying on the ramp, we could look at the sum of our forces in the y direction. That's our normal force minus mg cosine of theta. And we could do the sum of the forces in the x direction. And this time what I'm using as my x direction, this is kind of along the plane and normal to the plane. Okay, that's why my normal force is my y. So my directions here are, this is x and that's y, because it's easier to work with it that way. I get the mass of the block times gravity minus mg cosine of theta minus my force due to friction. Because I've got the friction that's holding my block up in static equilibrium. So if I rewrite this, I get m times the mass of the block minus the mass of the block, gravity cosine of theta. And I get my mu times my normal. And remember, we get the block. And I get mg sine theta. Oops, I'm sorry. You guys let me get away with it. It's Monday. That's sine. So sine theta minus mu normal mg cosine theta, because that's where my normal force is, because that's got to equal 0. So I get that. And so now I can kind of, if we do the block, the other fun part is, this is a 30-60 triangle. So here's one of my shortcuts. 30-60 triangle, the sine of the angle is 3/5. Cosine of the angle is 4/5. So I don't even have to know that angle. It's a 3-form triangle. I can just plop in the ratio.
So what is that at on the equation? It's minus the U, I can't remember what it is, the coefficient.
That's the coefficient of static friction.
Okay, US. That's what
Yeah.
I remember.
Mu s is the coefficient of static friction.
Oh, nice.
Yeah, that's a sub s, because remember when I have friction, I have two coefficients. I have one is kinetic when it's moving, and one is static. And remember that static friction is always greater than kinetic friction. So in this case, we can find a lot of different things. But when we're setting up our problems, that's what we're actually looking at. So why I actually did this was to show you the first shortcut. First shortcut is dealing with the sine and the cosine. I can use those fractions that we talked about on Friday. And the second shortcut is looking at my orientation of the system. Also, just to remind for giggles and giggles, just kind of, dusting off the cobwebs, right? Dusting off the cobwebs. If I wanted to do two forces or add forces, so if I gave you a force, and what we're going to see in here is we're going to use the forces in this format a lot, okay? We're going to use our forces in that format a lot. And when in doubt, when you start a problem, and we talked about dealing with this kind of paper, and I will get that posted. I didn't get a chance to post it over the weekend, but when I get that posted, so here's my force, and I've got it on my piece of paper here. When in doubt, when I want to start solving a problem, how do I want to draw this? This is a right angle, okay? This is a right angle, and we'll make this one a right angle. When in doubt, see if you can write your force out in terms of if it's x or if it's I, j, and k components, because that's going to help you start your problem. So when you're starting and working your problem, when in doubt, start doing it. Just write it out so that you've got it, because you can always do it the long way. If nothing else, you can always do it the long way. So now if I've got two vector components, I can do a minus 5j and a plus 3k. And if I want to do the resultant vector between the two, I can add these together, so I get 28i plus 4j plus 13k. And remember, if I want to find the magnitude, this is going to be the square root of 28 squared plus 4 squared plus 13 squared. And when I do that, I get the square root of 969, and that gives me 31. And then you can also do the angles, okay? You can also do the angles. And the way we do these angles is this is theta, and this one is phi. So when you do your angles, you get theta and phi. It's detailed in section 2.4 when we get there. But just kind of reminding yourselves of how to add those forces again. How to add those forces again. So let's do a problem here. Okay. I've got my lovely little boat.
I think so, yeah.
And I have what we call a mule over here, and I have what we call a mule over here, okay? This mule is applying a force degrees. This one's 30 degrees. This is a force of 60 kilonewtons. This is a force of 145 kilonewtons. And we want to know what's the resultant force. So we can look at this problem a couple of different ways. I'm going to do it the old-fashioned way.
All right.
I'm going to do it the old-fashioned way. So here's one force. Here's the other force. And I'm going to actually draw the parallelogram so that you guys can actually see the parallelogram, right? Because I can slide this force up there. And if I look at that, this is going to be my 30-degree angle, and this is my 30-degree angle. This will be my 25-degree angle. Okay? And we know that the resultant force is going to look like this. So this is the one we're going to try and find. And if I want to do some creative fun things, I can do a couple creative fun things. So we know that that happens to be 25 degrees. So if that's 25 degrees and that's 30 degrees, we can easily figure this one out. All right? Because that's 180 degrees minus 25 degrees minus 30 degrees is going to give me, if I'm doing that right, it's 180 minus 55. That gives me 125 degrees.
You took the minus 25 from which one?
This right here.
Okay.
Because if I do this whole angle, that's 180 degrees, right?
Mm-hmm.
And remember when I showed you on Friday, we looked at a bunch of trigonometry or geometry rules. If these are parallel, this angle has to equal that angle. So since we knew that was 25 degrees, we know that that's 25 degrees. Just a second. Let me find my handy dandy piece of paper that we showed on Friday.
Hmm?
If I know this angle, I know that angle. Because that comes from this right over here. So if I know this angle, I know that angle. So if I know this angle, I know that angle. And I drew this because I slid that vector up. Just did this, my transmissibility, slid that vector up. And so that angle is that angle. So now I get that this angle is 125 degrees. And of course I have my other little parallelogram piece here. So this gives me a lovely little parallelogram, so I have it. So I can add either vector either way, right? I could have slid this vector, or I could have slid this vector. So I can slide it either way. So I get my parallelogram. Okay? So I can get that piece. So we can do a couple of fun things. So now I've got my parallelogram, and I'm going to go over here real quick, and I'm going to show you guys something. Because this is where the shortcut is going to come into play in just a little while. Because when you see the answers to your book, or answers in the book, or the answers to your problems that you've already done, they're going to do it the shortcut way, and he might use the law of sines. Or he might use the law of cosines in order to get the different parts of that triangle. And the triangle I'm going to be using is this triangle right here. So if I go back to my parallelogram.
What page is that? I've got students asking.
Okay, just a sec. So this one, this is in the FE handbook. It's on page 23. Is it coming? It's on page 23.
And it's like $14 shipping.
Yeah, you may as well just get it on Amazon.
Is Amazon, can you get it on Amazon?
No,
Yeah, it comes out to the same price.
Yeah,
Their website shows it's only like $14, but it has like $15 shipping on top of that, so.
Okay, but if you could get it on Amazon, you have Amazon Prime, you get
Yeah.
second day free shipping.
yeah,
Yeah.
So, I didn't know whether or not you could get it on Amazon. so.
yeah, it's there.
Okay, it's there on Amazon.
I think it's
so.
like 26 something, but you get free shipping.
Oh, okay, it's $26 if you buy the book, so it's a wash then.
Yeah.
It's a wash. But this is on page 23. So, so that's where, but that's gonna be one of the shortcuts that we show. Okay, but I'm gonna do it, like I said, I'm doing this the long, gory way. Okay. Is it doing this thing? Okay.
Yeah,
So so when you draw your picture, you can get your parallelogram. So depending upon what question that they're asking, will depend on which way you want to work the problem. But let's do it the long, gory way.
What would you use for the side links? That,
Well, this one,
145.
this side is 60 kilonewtons.
okay.
This side is 145 kilonewtons. So you do have this side and you do have this side because this one is 145, this is 145. This side is this side, so this is 60. So you do have your sides.
And so would you use,
So depending on what you want, okay, depending on what you want, if I want to use a lot of cosines, I've got my A and my B and this angle, so that would be angle C, and I'm trying to solve for the side C. You would use the appropriate law of cosines to solve for side C. So you can draw the picture. So like I said, I'm doing it the gory way. I'm doing it the long, drawn-out way, so you always have the long, drawn-out way that you can do it, then you have the shortcut way. So here's my lovely handy-dandy picture. So if I do this, and I rewrite out my force one, and this is gonna be the 145 kilonewton one. I'm gonna do the 145 kilonewtons cosine of 30 degrees in the I direction minus 145 kilonewtons sine of 30 degrees in the J direction. So I just wrote my I and J components of that vector. Okay, I just wrote my I and J components of that vector. I do the second one, and that's going to be my 60 kilonewtons. So that's 60 kilonewtons cosine 25 degrees in the I direction, plus 60 kilonewtons sine of 25 degrees in the J direction. Now remember, the reason I'm doing the minus is because this 30 degrees is below the horizontal, this 25 degrees is above the horizontal, so I've got my X and Y components. If I plug this into the calculator, I get my 125.6 I, this is F1, minus 72.5 J. And then if I do F2, I get the 54.4 I plus 25.4 J. And then I could just do the simple arithmetic. I get my R. I add the 125 and the 54, I get 180. I add 25.4 minus 72, I get the minus 47.1 J. And then I do the magnitude, and that's the square root of 180 squared plus 47.1 squared. And that gives me 186 kilonewtons. And I plug in for the angle. When I go back and do the angle, I get 14.7 degrees.
How you go plug in for the angle?
The tangent of theta is going to equal my y minus 47.1 divided by my 180. But now if you can
Would
see
that
by
be,
doing, what?
like, would you put tangent negative one, like the inverse tangent on that?
Yeah, you have to
that's
do the
what I
inverse
did.
tangent, that's the tangent of the angle equals that, and you have to do the inverse tangent. So when you do this,
Can
you
you
know
slide
that,
that up, please?
when you do this, you know that that has to be the negative, and that comes in right there, and it gets you into the negative.
Cool.
But now you can see why going straight to the law of sines and the law of cosines, it's one step.
What side would you use for the angle, like for law of sines?
Well, for law of sines,
Could you
one
do
of the,
that right off the bat?
let's see if we can do, so we know that angle, right?
Yeah.
So if I know that angle, so I'm gonna write, I gotta keep all my stuff straight. So if I know this angle and that angle is C, so this is gonna be side C.
So, do you have a question for her?
Okay, the question that it's asked is how would you do it by law of sines and law of cosines, and where would you pick your angles? So that's what I'm getting ready to do, okay? So this is gonna be A, and this is gonna be B, okay? That's A and B. The other challenge is getting your different angles here that you wanna have. Okay, so we can do C. So if I do my C, so I get C squared is equal to A squared plus B squared minus 2AB cosine of C. We know that angle, so that's gonna give me my side. Okay, so that'll give me my side. So once I've got my C, I can do a couple of different ones. I can do C over sine of C to get me my, and if we want to find this angle, okay, so we want to find that angle, making sure I've got it right. So that's A and C, this is angle B. All right, so that's angle B, so that's side B. That's gonna be B sine B. Okay, B sine B. So if I know C now, I know this C, because I know the resultant force. So sine of B is gonna be B times the sine of C divided by C. But that's gonna give me the 25 plus the angle I'm trying to find.
So that line goes,
This B goes from here to my resultant force.
okay.
So that becomes 25 plus the angle you're trying to find, and alpha, which is gonna end up being 14.7 degrees.
Yeah, so you just subtract from that.
But it's certainly it's certainly a lot simpler to do it that way than to go through all of that.
Yeah.
Now, that now gives you, here's the kicker. That now gives you two ways to do the problem, so you can check yourself. I mean, that now gives you a way to actually check yourself and make sure that you're doing it correctly, because I can do it by law of cosines, I can do it by law of sines, and I can actually check myself and say, okay, did I make a mistake? Am I on the right track? Am I there? But if you went to Chegg to try and solve the problem, guess which way Chegg's gonna do it? It's a lot simpler. And you're going, where did all that come from? You know, and that's the kicker. Where did all that come from? So my recommendation for you guys when you work these problems, and I'll set up another one for you. I'm gonna set up problem 20-2, or 2-20, okay? So that's the problem I'm gonna set up, and I will show you the handy dandy picture. It's in the other section. That's 10. Okay. All right, so let's look at this problem. I'm gonna zoom in. No, really? Okay, so I have a box. This is a box. It's not like we haven't seen boxes like this before. It could be a plant box, it could be a toy chest, it could be a variety of things. So I've got this box. And I have two forces that are being applied to the top of the box. I have a force Q that's going up this direction, and I have a force P that's going this direction. So the two forces are applied to the lid of the storage bin as shown, knowing that P is 60 newtons and Q is 48 newtons. This one is asking you to determine by trigonometry the magnitude and the direction of the force of the two forces. Okay, it's asking you to go ahead and do it by trigonometry, the magnitude and direction of two forces. So you can do the law of sines and the law of cosines. You can do it the old-fashioned way to give you gory details. So let's look at it. So that's what we've got. That's the problem that we've got. So if I'm drawing my picture to present it to you guys, here's my storage bin piece. Okay,
It's still zoomed in.
it's still zoomed in. There's my storage bin piece. And I can go back out. And now I've got two forces that are being applied. We're told that this is 25 degrees. We've got a force that's being applied not quite at 90 degrees. This is 55 degrees. And we've got a force that's being applied, and we're told that that's 85 degrees. And this one is Q, this one is P. Q is equal to 48 newtons. P is equal to 60 newtons. So now I've got, if I want to do and look at force P, so when in doubt, even if it tells you to do it by trigonometry, when in doubt, what you can always do is do it this way. You got PX in the I direction plus PY in the J direction. We know that P is 60 degrees, or 60 newtons, sorry, 60 newtons. And we know that we've got the cosine of 25 degrees plus 85 degrees.
What's the magnitude and direction of the resultant force? Is that
Yeah,
what
we want the
is?
magnitude and direction of the resultant force.
So why would it be? Oh, okay, I see.
Now, that's where the first mistake, as I was about to tell you, your most common mistakes are, when you do it in terms of X and Y, make sure you've got the right angles that you're playing with. That's the angle that I need. Or, I can do it the other way and find that angle, whichever one you want to do, but then I gotta keep my positives and negatives straight.
Sorry, I missed it. What's the angle you need?
For P, I need this angle right here.
Oh,
And that angle is the 25 degrees plus the 85 degrees, which is gonna be 110. And then for the PY, that's gonna be 60 sine 25 degrees plus 85 degrees J. And when I do that, I end up with a negative 20.5 newtons in the I direction plus 56.4 newtons in the J direction. We can do the same thing for Q. And in this case, it's 48. And that's the cosine of 25 plus 55 plus 48 sine 25 plus 55. And that gives me 8.34I plus 47.3J. And then you go through the same process that we did before. You add the two vectors, do the sine and or do the tangent and the angle. But, so So if I do the sines and cosines, or drawing my triangle the way I need it, I'm gonna draw the triangle so I can use the trigonometry. So here's my Q. So this is Q. Q is 48 newtons. And we were told that this is 25 degrees, and we're told that this is 55 degrees. So this angle ends up being 25, 55, this actually ends up being 80, right? That ends up being 80 degrees. Now I'm going to add my other vector. And we know that that's P. And P is going to be 60 newtons. And we know that this angle is 110. So I've added head to tail. I'm using my parallelogram. Here's my resultant vector. There's my resultant vector. So now I have my A, I have my B, I have my C. We can figure out this angle right here by geometry. So I have this angle, so if I do this as little a, little b, c, this is little c. I can use my law of cosines in order to get my result, my magnitude of C, because that's going to be, flip it over here. This one is going to be C squared is going to equal A squared plus B squared minus 2AB cosine of C. And then I can either use law of cosines to find my B and my A, or I can go ahead and use my law of sines, depending on which way I want to do it.
So what would we put in for the big C?
Well, this one, if this is 80 degrees, this has to be 10 degrees, right?
Oh, yeah.
Or whatever. This is 80 degrees. No, that becomes 80 degrees. And then this becomes 110 minus 180, so this is 70 degrees. So 70 plus 80 gives me 150. So my C is going to be 150.
That's pretty
So it's all about setting up the triangle.
cool. We're just trying to find the side of C.
Well, you want magnitude and direction, right? Well, if I already know A, I know B, and I know that angle, I can use one equation and go find it directly. Versus going the old-fashioned route of doing it at addition that way. But again, gives you a check. Gives you a total check on how to do the problem. All right, I'm gonna leave it there. I'm not gonna do any more. You guys are gonna do problems on Wednesday.
So here we go. That where the little a is.
Okay, the question is where the little a is, yeah?
And if you go over to the left, that's the angle B, right, inside that triangle.
Yeah,
they're like
this is
across
angle
from each
B.
other.
Yeah, this is angle B, and this is angle A.
So would that be 10? Would you say that's
This?
90 or no?
No, because this is, remember, this angle B is between this side and that side, and that's not 90 degrees, because this is the resultant force. That's not 90 degrees.
Okay.
And I've exaggerated it on this piece of paper just to be able to write into it. You guys got questions over in Enid? Are you good? Can't hear ya.
Jeff, George, you gotta.
I can't hear you. Step up close to the microphone. I'm still not hearing you guys.
Are you hearing me?
Yeah, I hear you just fine, Bev. Okay, you'll get me later? Okay.